When we discussed the car example, I mentioned that every time when a new car object is being created using the keyword new, memory space needs to be allocated for storing all the relevant information about the car object. The diagram here illustrates the information needed in representing an object in car2. This is the constructor we defined for car2. When a variable of car2 is declared, memory space will be allocated for the variable car of John. When a new car object for car of John is created using the new operator, memory space will be allocated for all instance variables belonging to that object. Similarly, when another instance of car2 is created, memory space will be allocated for the variable car of Mary. When the object is created using the new operator, separate memory space will then be allocated for the object car of Mary. The memory space for local variables is called the stack, and the memory space for instant variables are allocated from a heap. Notice that instead of putting a value in the memory cell for car of John and car of Mary, I am using arrows to indicate that the value being put in those cells are reference addresses. Let me further explain what that means. When we discuss primitive types, such as integer and floating point numbers, we use mailbox as an analogy for memory space allocated for variables declared in primitive type. For example, when a variable with the name tc of primitive type is declared, a mailbox will be labeled as tc. When the variable is initialized with certain value, the value will be stored in the corresponding mail slots. Such memory allocation scheme is okay if the type has some predefined sizes. What if we have large puzzles coming in that won't fit into the mailbox? A large puzzle can be considered as an analogy of the complex structure used in objects such as the car or causeway object that we have seen. Similar to what a mailman would do when a parcel is too large to fit into the mailbox, he or she would put the parcel in the mailroom and leave a note in the mailbox with instructions on where is the address for collecting the parcels. So instead of storing information on the instance variable together with the primitive types, the storage allocated for reference types will store the reference address on where the instant variables are actually located. Let me use the table here to summarize our discussions on class, instance, and local variables. Local variables are declared inside a method or constructor. Parameters used in a method or constructor are also local variables. Class and instance variables are declared inside the class but outside methods or constructors. In the case of class variables, the keyword statics is used. Local variables are declared when a method is entered. They are used for holding intermediate results, acting like short-term memory. They will be destroyed on exiting the method. A separate copy of instant variables is created for each object when the keyword new is used. Java would reclaim the memory through a process called garbage collection when no more reference is made to that object. Only one single copy of static variable is created for a class without the need to instantiating any object. They exist from the start to the end of the program. Here are some examples of different types of variables that could be used for the class of car. We pointed out in the example that getUse is local to move forward and couldn't be used in another method such as addGuess. These are some of the instant variables. We can declare a static variable num of wheels to specify that all cars have 4 wheels. It is also declared as final, that is a constant. Notice also that we often use all capital letters for naming convention for constants. As discussed before, all local variables must be initialized before they can actually be used, otherwise it will lead to a compilation error. Java provides default values for instance and class variables. All types of variables followed the scope rule that we just discussed. Since local variables are only meaningful within methods where it's declared, access modifiers cannot be used for local variables. Instant variables are often declared as private in order to protect them from being accidentally changed. And class variables are often declared as constants.